Hi everyone, welcome to the video. We're going to solve a hard lead code question, which is minimum insertion steps to make string palindrome. Here we are given string and we have to return the number of characters which we need to add to this string in order to make this string a palindrome. So in example 1, since the example 1 is already a palindrome, we need not add anything to it. For example 2, mbadm. Okay, we can add two characters, either this d over here and b over here, or this b over here and d over here. Okay, so this will make it a palindrome. Similarly, in example 3, you can see the string input is lead code. We can add five characters, which are o, c, t, e, and this l at the end, which will make it palindrome. So how to do it? I have this length of string which I will calculate. But if we have longest palindromic subsequence available in this input, we can always subtract it. I mean, if we can find what is the maximum palindromic subsequence out of this given string. Okay, so we will get, okay, these are the palindromic subsequence. For example, in example 2, let's see, the string length is 5, but what is the maximum palindromic subsequence? It is 3, m, a, and m. M, A, and M is the maximum palindromic subsequence, MAM, out of example 2's string. And how many characters can we add or delete to make it palindrome? We can obviously remove two characters, which are B and D, from first and third index, in order to make it a palindrome. But similarly, apart from deletion, we can even add those strings at different indexes to make it a palindrome. So this will be our solution. We just need to find the maximum length of maximum palindromic subsequence. Then we will subtract it to the length of the given string. I will be using dp for this question. First of all, let us store this length of a string. dp dp will solve, just find maximum palindromic subsequence using the longest common subsequence method. Let me initialize the dp. Well, and since and again one thing, what will be so in longest common subsequence or palindromic subsequence we need two strings, but here we given only one string. Okay, so as we know, what is palindrome? Palindrome is same from front and back, both the sides. So if we pass this reverse of given input string as the second string, which will yield us, it will yield us the maximum length of maximum palindromic subsequence. That is what we do to calculate the LPS of a string. Okay, now I will try to fill this DP for in range 1, 2, and plus 1. I'm starting from 1 because if length of either of the string in LCS is 0, then there will be nothing common. And similarly, we do for the LPS, since LPS is the you know additional execution of the LCS method. So if the last character, I will just calculate the second string also. It will be reverse of this input string. If as last character of a string 1 is equal to last character of a string j, string 2, that's the case, then we will store diagonally previous cell value and add 1 to it, so that we can understand we have reached one step ahead, one character ahead of it. And if that's not the case, then we have to choose between two conditions. We will choose maximum of those conditions. We will take first string completely, and we will take the second string by removing its last character, or we will take first string by removing its last character and take second string completely. Either of the maximum of either of these will help us reach the value. Okay, now at the end we'll just store this value, the last cell value of dp is the lps length, and at the end we just need to return n minus lps length. This will help us get number of insertions or deletions, both. Okay, okay, sorry, I have to. Okay. So if he is asking minimum number of insertion or minimum number of deletions, in both the cases our solution will be same. It just, how we approach the solution, how it is asking in the question to approach us. So as you see, it does the job. This time it is taking, pretty somewhat more time than it did previously. Earlier it was able to solve in 60, but it was able to beat 60-70% of Python E3 users, but this time it is beating only 50%. But we can always optimize the solution. The main thing is to solve a hard question of lead code efficiently and in easier method. So I hope you enjoyed it. Thank you. Have a nice day.